Good afternoon. Today I'll update the Lake Committee on the high-tech acoustic initiative on Lake Superior, mostly focusing on Lake Superior. We've done work on other lakes, but I'm just going to share Lake Superior results. I have a lot of credit to give to my co-authors. They are the ones that produced all of the great products I'll share. I am merely the good-looking front man, of course, the Brad Pitt of the work group. Would you give me George Clooney? Okay, I can aim this and go. Is that obvious? Oh. By way of an outline, I'm going to start by sharing the results of 4 prior lake-wide surveys for pelagic fish that have been done since the turn of the century. I'm not going to update the committee on the high-tech acoustic initiative. The purpose of the initiative is really to improve the lake-wide surveys to have better estimates of abundance of biomass of pelagic fish. We did this in a couple ways. In 2022, we set sail what's called a long-range autonomous underwater vehicle. It has both mobile up-looking and down-looking capabilities. And here we were interested in learning what proportion of fish we missed in what's called the surface acoustic dead zone, or the SADS. It makes me very sad when we miss fish in the surface waters. That same year, we set sail a sail drone. It's made by a California company with the same name. It's solar-powered, wind-powered, and it has down-looking only capabilities. It's a very quiet platform, so we compare the sail drone results with that of ships to understand how ship noise may be influencing overall results by comparing it to the results of a more quiet platform. 2024, we asked a totally different question. I'm excited to talk about it today. We asked sail drones if they could pull off a lake-wide survey. And here the scientific goal was to estimate how many H2 Ciscos remain from the banner recruitment year of 2022 that we've heard about today. I'm going to try to stitch everything together at the end in a summary. We've done a total of 4 lake-wide surveys. The first one began in 2003 and ran for 4 years. We essentially divided the lake into quadrants and sampled 1 quadrant per year. Beginning in 2011, we began to use what's called the Cooperative Science and Monitoring Initiative design. It's shown on the map to your left. It includes 56 stations. It's depth stratified and a spatially balanced design. Because these lake-wide surveys are tied to the CSMI, or the Coordinated Science Monitoring and Funding, they occur rather infrequently or at about 5-year intervals. You can see the graph of the 4 lake-wide surveys on the right. The abundance of Ciscos had been in decline. We used stacked bars here to show the different species, but all that changed in 2022 when the enormous year class of Ciscos recruited. It increased the abundance of Ciscos by at least an order of magnitude. I think this design does a really nice job of letting us speak about lake-wide abundance, but it's been my experience that fisheries managers on the lake covet information about the abundance of biomass of prey fish at smaller spatial scales, like the lake management unit level. And so, you know, there's also a movement afoot to incorporate bioenergetics models into the lean lake trout catch at age models. So they are coming online, and we're going to soon have consumption estimates on the lake-wide management scale. I think it behooves us to provide similar estimates of prey fish biomass at that same spatial scale. Quickly, we evaluated 2 different drones here. The long-range AUV is manufactured by the Monterey Bay Aquatic Research Institute. It has up-looking and down-looking capabilities. And sail drone was manufactured by a company of the same name out of California. It has down-looking capabilities. When I show these pictures in the upper left-hand corner, you'll know which drone collected which data. If you see the picture on your right, I know that's when I'm comparing sail drone to ships. A little background on the Triton. It has about a 500-kilometer range, and it has to porpoise periodically in order to acquire satellites to learn where it is. 500 kilometers works out to be about 10 nights, and then it has to be brought back in for a battery charge. Every time it porpoises to acquire satellites, it acquires what amounts to as a CTD class. So we get really great environmental data to help us interpret the fisheries acoustic data it collects. Travels at about 3.0 kilometers per hour, which equates to 1.6 knots. And like all platforms, the quality of the up-looking data is going to be sea state condition. When there's wind, there's waves, bubbles get entrained into the water column, the upper water column, it becomes impossible for us to discern bubbles from fish in high wave conditions. We launched this with a kayak. We pulled out to deep water with a kayak. We learned that we can deploy it off of a ship crane and actually calibrate the transducers before we deploy it off of our larger vessels. So with this AUV, we are trying to get at what we miss in the acoustic surface dead zone, or the SADS. Ships and sail drone, for that matter, have this surface dead zone because the transducers have to be deployed some depth below the water surface. And also, when the transducer vibrates to form a sound wave, it takes some distance for that sound wave to fully form. Any echo that would return to us before that echo is fully formed is called in the transducer near field, and the results are nonsensical. So we don't calculate that in our density estimate. So usually it's about the top 5 meters that ships and, again, sail drone do not sample. The echogram on the right is collected by the Triton. It has the 2 channels shown on the same echogram. The hot red color at the top of the echogram is the surface. On the y-axis is the depth of the water column. You can see the bottom of the red hot echoes near the bottom of the echogram. Here the Triton was sailing at about 30 meters of depth. You can see very high densities of fish present in the 0 to 5 meter depth zone, and these were the H0 Ciscos that were collected during 2022. We ran a total of 7 transects with the Triton, deploying at about 30 to 40 meters below the surface. With the transect shown on the map, we then produced this target strength frequency distribution. We're showing data in 5 meter high layers on the y-axis. On the x-axis is the acoustic size of the fish measured in decibels. On the left-hand side, it's small fish. On the right-hand side, it's large fish. We saw a lot of very small targets consistent with the H0 Ciscos in the surface waters. Between 20 and 30 meters of depth, we see a bimodal or 2-mode distribution, which is consistent with yearling and older rainbow smelt and yearling and older Cisco that occupy those depths. In the very deepest waters, we see a unimodal or single mode, which is consistent with the yearling and older Cisco, deepwater Ciscos like Kai and bloater. Hannah Blair is a postdoc at Cornell University. She's been processing the Triton data. What she's calculated here is what proportion of the abundance of the fish for the entire water column was present in the top 0 to 5 meters or in the surface acoustic dead zone. She found the median estimate. There's a lot of spatial variability here, but for all fish, it was 32% of fish were present from the 0 to 5 meter layer. She then looked at 2 different sizes of fish, targets that were consistent with the YOYs and targets that were consistent with yearling and older. And she showed that 55% of the young and year targets in 2022 were in the surface acoustic dead zone and would have been missed by vessels, but only 3% of the yearling and older fish were missed. Sail Drone is a company in California. USGS contracts them to do surveys. We upload a mission into their portal. They assess it for feasibility. They agree to do it. They notify the Coast Guards of the 2 countries that the sail drones are going to be operating. They put out maritime notices. They also do work to try to keep the drones safe by putting a strobe light at the surface. They paint it bright orange. And so we've had no conflicts with anybody out sailing on the lake. The transducer is put on the keel, so it has that same surface blind zone that I talked about with the ships. Another thing about sail drone is when it is not windy, they lose the ability to navigate. So they're reticent to take their sail drones into really close to the coast or in between islands, say in the Apostle Islands, into bays like Black Bay, Thunder Bay, and also heavy traffic areas, because they simply lose control if the wind isn't blowing. 2022, we compared the sail drone estimates to fish survey vessel estimates. We ran what we call overtake experiments. We let the sail drone sail for 2 kilometers, and then a research vessel would come behind it and follow in its same path, traveling faster than the sail drone. It would eventually overtake the sail drone. That's the name of the experiments. We ran a total of 44, I think it was, with 5 research vessels during 2022, and this work was recently published in CJFS. And we looked at several things like the backscattering levels, which is the amount of wave energy returning from fish in the water column in different layers, the average target strength, the average target depth, and also fish density, which we get at by taking the backscatter and scaling it by the average size of fish. We can estimate fish density. All said and done with all these overtake experiments, we learned that sail drone provided us density estimates that were on average 15% higher than the vessels, but not a lot of difference there. We found there were no systematic differences between the vessels. There was no vessel because of its ship noise that disturbed fish more than any other, so all of the vessels seemed to perform similarly in the fleet we tested. We concluded that sail drones can serve as a surrogate for acoustic vessels, and said differently, any time series built with vessels can be extended with sail drone. So in 2024, the plan had been to use the high-tech tools on Lake Ontario. They declined. I raised my hand, hey, let's bring them back to Superior. Let's get them back here, let's see what we can do. And so that's what we did. We ended up sending out 2 sail drones for a total of 42 days from the middle of August until the early October of 2024. I picked this time period because of the wind conditions. These 2 drones traversed over 5,500 kilometers of data shown in the map to the left. The goal here, for the scientific goal, is to estimate the abundance of H2 ciscos, again now at H2. We are busy processing these data, and we will be able to prepare those results at the summer 2025 Lake Superior Technical Committee meeting. But the drones were up to the task, and they proved that we could provide management unit level coverage, and that was possible with the drones. And also the drones can accomplish things that other things like a ship find difficult. Now the map on the right is what was accomplished at night. There are 84 night segments here. And what's particularly powerful to me is the coverage in the eastern end of the lake. This is a very difficult place to sample because it's so far from shore, and we have very few ports there, so we have to drop anchors, which means overtime costs. The sail drones accomplished this work out there. There was no complaints, and no one got on me about how much money I was spending on overtime. Again, we're wrapping this up. We're going to share the results this summer. A lot of the data that we're collecting with sail drone, we're actually using AI or machine learning to process, like where the bottom line is. We have to exclude the bottom from the fish backscattering layer. There's also surface bubbles when high seas, and we're using AI to draw those lines to exclude that as well. What used to take months to process 5,500 kilometers now takes weeks, much faster. Really great echogram. Have wonderful signal to noise ratios. We can see very small fish at depth. Here, 30 hours of transect showing very small fish down at about 140 meters off the bottom during daytime. At dusk, they migrated up in the water column where they resided between 10 and 20 meters, and then at dawn they drop back down. These are no doubt the 2022 enormous year class of Kai in Lake Superior. Another echogram showing very high densities. I've been doing acoustic surveys on Lake Superior for 20 years. I haven't seen anything quite like this. Very high densities along this 3 kilometers of segment of fish in the pelagic zone. Of course, the echo sounders can size fish, they can give us densities, but they can't tell us the species, so we went out and collected some midwater trawl samples at the end of September with the RV Kai. We sampled 25 sites, shown with the yellow circles. Until the acoustic data is fully processed, I like to look at this first. It's the number of cisco here, the species caught per kilometer of trawling. So on the y-axis is number caught, on the x-axis is the different survey years. The 2024 survey shows very high densities of juvenile cisco being caught here that were about 225 millimeters or so at the end of this growing season. We actually see an uptake in the blue bars, which is the catch rates of adult cisco, or those greater than 250 millimeters. And there's some photographic evidence of the fact that Lake Superior currently supports a hell of a lot of H2 ciscos. So to wrap things up, the long range autonomous underwater vehicle can sample the surface acoustic dead zone where juvenile fish were present in 2022. In most years, I think that the surface waters would be predominated by rainbow smelt, age zeros, so I don't know how useful that would be to fish managers to enumerate them. But we have new abilities to forecast earlier the strength of cisco recruitment events based on meteorological data. And I proposed that if we were going to do an acoustic survey and it looked like the conditions were good for Cisco recruitment, that we would try to find a way and scramble and get long-range AUV into that overall design. I think the big take-home for me is that sail drones can be a surrogate for vessels and they can extend time series. I think a huge thing is that it appears to me they can provide management unit level estimates of fish abundance in a given year. They have strengths. They can sample these tough to reach places and offshore waters they don't worry about over time. And their weaknesses is that, you know, you would need some vessel support to sample the bays within the islands and the heavy ship traffic areas, but much less effort could be devoted to ships and rely on the sail drones for the bulk of the heavy lift. I have an idea proposed here that we could increase the frequency of pelagic fish surveys from now every 5 years to more frequent by undertaking the offshore bottom trawl survey that Nicole talked about, doing that survey in even years and using drones complemented by vessels to overcome drone weaknesses during the odd years. So I think we could get, again, biomass and abundance estimates at the fish management unit scale. I will close with the notion that there's a lot of H2 Cisco's in Lake Superior from the record 2022 cohort. With that, I thank you for attention, and I'd gladly answer any questions.